Continuing our series on vectors. Now we're going to talk about some of the built-in functions or library functions that exist in Matlab to use on vectors, which come in very handy. Now this is not an exhaustive list. This is a list of some common ones that we use. There's a whole lot of help in Matlab that you can get to learn about other functions, but these are some of the common ones that we use. Let's jump right in here. First one would be sum, which does exactly what you think it would. So if we had vector A equals 1, 2, 3, and we did B equals or gets the sum of A, then B is going to be the value 6. It's just that easy. You just add up everything in the vector. So you can always get the sum of a vector. If you want, you can do the mean, which is the average of a vector. So if I was looking at C equals the mean of A, then C would equal 1 plus 2 plus 3 divided by 3, which would be the value 2. Okay. So it's just the average of all the elements in the vector added. Okay. Next we have min, which returns the minimum or the smallest value in the vector. So if I had D equals the min of A, it's going to just return the smallest value, so D is going to be 1. Now there's a bit of a caveat with min. Min actually returns 2 values, but Matlab is smart enough to know that if you only give it one value on the left hand side, it will give you the minimum value. But if you give it 2 values on the left hand side, so let's say if I gave it a vector E, F, equals min of A, the first value is actually going to be the value, so it's going to return E comma F is going to get the vector 1 because that's the minimum value, but the next slot is the location of that minimum value, which in this case is also 1. So if you give min 2 elements on the left hand side, or a vector of 2 variables on the left hand side, Matlab is smart enough to know that it's going to give you the minimum value and then the location of that minimum value, which comes in handy a lot of times. So just be mindful that if you give it one thing on the left hand side, it's just going to give you the minimum value. If you give it 2 things, 2 variables, a vector with 2 variables in it on the left hand side, it's actually going to give you the value and the location. Okay. Same thing if I come over here. We look at max. Well, max does the same thing min does, except for it gives the maximum value. So once again, if I have H equals the max of A, then H is going to get the value 3. But if I come in here and I say I comma J equals the max of A, then I comma J is going to be the vector. The max value is 3 and the max location is 3. So that's what you're going to get. So those are sort of the numerical ones. There are many others, but just to give you an idea, some of them return scalars like this. Some of them are smart enough, like min and max, to know what you're asking for and to be able to adjust what they give you. And so there's a ton of help and contextualized help in Matlab, but this gives you an idea that there are these built-in functions for vectors. So there are also functions, library functions regarding rounding and that kind of stuff. So let's see how that works. If you did, there's a function called round, which rounds like normal round, like we normally would round, which means that everything with a 0.5 and greater goes up, and everything less than 0.5 goes down to the previous number. So if your number is here, then anything 0.5 goes up to the next number, and anything less than 0.5 goes down to the previous number. If you're on the negative side of the house, then that holds as well. So let's look at this. If we had, let's say, A, once again, equals the vector negative 3.5, I don't know, and 3.5. And we do B equals round A. Okay. What's going to happen is B is going to get and become the vector. If I round negative 3.5, what I wind up getting is it actually rounds to negative 4, and then 3.5 rounds to 4. Okay, so that's rounding. There's the idea of ceiling, which takes a number up to the next highest value. So once again, if I did C equals ceiling, if C equals the ceiling of A, then it's going to be element by element, just like it was with round. C is going to get negative 3, 4. So this concept of ceiling implies that numbers sort of go positive infinity, negative infinity, 0 in the middle, and the ceiling is up here, and the floor is down here. So if you're doing ceiling, it's going to take things always up towards this way. So that's why when I do the ceiling of negative 3.5, I get negative 3, because it's going to go up towards the ceiling. And in terms of the number line, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Negative 3.5 is in here, so I'm going to round up that way, which takes me, I'm going to take the ceiling up that way, which takes me to negative 3. And 3.5 is here, I'm going to take the ceiling up this way, which takes me to 4. Likewise, if I do the floor, then it's going to take me down. D equals floor of A. And so D would wind up getting, it's going to go negative 4, comma 3, because the floor is down this way. So for negative 3, it's going to go down that way, and for positive 3.5, it's going to go that way. So negative 3.5 is going to take you down to 4. Positive 3.5 is going to take you down to 3. The other one is fix, which is round towards 0. So instead of doing like ceiling and floor, where there's an absolute up and down, round towards 0 does this. If you have, I guess the drawing would go positive infinity here, negative infinity here, with 0 in the middle. 1, 2, 3, 4, -1, -2, -3, -4. You're going to round always moving towards 0, or you're going to move towards 0. So if you had E equals fix A, then E is going to become -3, (3), because you're going to be, if -3.5 is here, you're going to move towards 0, and positive 3.5 is here, you're moving towards 0 as well. You're simply really truncating, you're taking the back part off, and so fix gives you -3, (3). These are just a few of the functions: round, ceiling, floor, and fix, that are built in to Matlab. So we'll encounter them as we go. There's plenty of online help, but I just want you to know that there are a lot of them out there. Some of them work element by element, and some work on all the values of a vector. So this is the Matlab reinforcement for the video board lecture of library functions. So if I have A equals the vector 1, 2, 3, and I do B equals the sum of A, and I execute this. I've already saved this, so it's not going to ask me to save it. I get B equals 6 over here in the workspace. If I do C, there are a couple of functions that I'll cover here that I didn't necessarily cover in the video. If I can do the sum, then it makes sense that I can also do the product. And so C, PROD, gives you the product of the vector A, which is also 6 in this case. You can do the mean, which is the average. So let's go. D equals the mean of A. I run that. I get 2, which is the average. We talked about also this idea of min. So if I give min, if I just put one variable over here on the left, Matlab's smart enough to just give me the minimum value, which in this case is 1. But if I put a vector on the left, then it gives me the first location is the value, so the minimum value is 1, and the second one is the actual location. So that's how that works. And the same thing with max. So the max of the vector is, the max value in the vector is 3, and with this one, it's going to, I is going to give me the max value, and J is going to be the location. In this case, both of those are 3 as well. Some more functions that I went over on the board are rounding, ceiling, and floor. And so let's take a different vector here. Let's do K equals and if I do round K, round K, then K equals that vector, and if I round everything, I'm going to round -3.5 rounds to -4, and 3.5 rounds to 4. Take the ceiling, concept of the ceiling is that you move towards positive infinity. So the ceiling of vector k, so it's going to move negative 3.5 to 3 to negative 3, and 4 is going to go to the ceiling. Let's see, the 3.5 is going to go to the ceiling 4. Likewise, you can do the 4, which is moving everything towards negative infinity. Which means negative 3.5 is going to go to negative 4, and 3.5 is going to go to 3, positive 3. And then you have fix, which is rounding towards 0, which is effectively truncating. So negative 3.5 is going to go to negative 3, and 3.5 is going to go to positive 3. Okay, so those are just some quick functions, but let me show you some of the Matlab help that's available with functions, which is why I don't have to necessarily be so inclusive of all functions, because there's a lot of help. First of all, if you right-click on a function, if it's a valid function, and hit open, it actually opens up a window which talks a little bit about that function. Sometimes it's very helpful, like in terms of if you do sum, you get something that's very helpful there. You can always right-click on a function to see something. Also, you can also go down here in Matlab and type in help, and that will give you help on a particular function. So if you just type in help, just general, it brings up a lot of directories for help, which you might not want all that. Let's clear this screen so you'll see. But if I do help on a particular function, sum, then it goes through and gets me help just on the summing function. And so you can type in help and then the name of something, and it actually gives you help there. Also, up here on this toolbar, you can browse functions. It says you can browse by hitting this button or hitting Shift F1. So if I hit that, it brings up a whole library of functions. Linear algebra functions, polynomial functions, elementary math functions. So if I want trigonometry, those are the trig functions there. So it goes on and on. So what I wanted to do here is give you some basics. But as you can see, there's plenty of help out there for all the functions that you might need.